And the recording started.
All right, thanks, Daniel. So on behalf of the Meridian team, I'd like to welcome you to this second workshop on ocean data management. So this is the second workshop in a series of 4 workshops that we're running this week and next week. Today we will have Kim Mortimer, who's a data manager with Meridian. We will have Kim discuss and demonstrate how best to describe your data and more generally talk about metadata. So with that, I'll pass on the word, the mic and the floor to you, Kim. Please take it away.
Thank you very much, Oliver. I'm happy to be doing this presentation today. I'm hopeful that it will introduce some people to the idea and some best practices dealing with metadata that they might not have been aware of. Unfortunately, due to limited participation, a hands-on part isn't really feasible for me to do live today, but I will leave it up as an exercise to the reader, and I'll do an example of what you could be doing if you decided to do this as an exercise on your own time. So hopefully that's helpful. I'd also want to give a shout out to my fellow data management team members at Meridian. Although they didn't really participate in making this presentation, I wouldn't be here without them. Sarah Bella, Casey Hilliard, formerly of Meridian, Ines Hessler, formerly of Meridian, Ryan Goss, formerly of Meridian as well. So thanks so much. Metadata is essentially how we describe things. So it's easiest to start by asking how we describe things. And my favorite example is a book. If you have a favorite book or something, maybe you can even just put it in your hands right now and or you can just visualize it in your head. A book with no cover, no title on the front, no author inscription, no price, no details on publisher or anything, is pretty bare. It's literally just the text on the page, just like a number of scientific papers you've probably read or like research papers you've written for your school or something. But the book is still there. The title doesn't really add anything to the book, right? It's not meaningful. You never judge a book by its cover, is the saying as it goes. But equally, without a cover, if every book was just a pile of pages with words on them, you would never be able to tell your books apart without reading them. You can't identify one pile of papers out of another in a pile without, turning through and, oh, I recognize this as Ernest Hemingway. I recognize this as Moby Dick or something. The cover and the starting pages of a book are really the metadata of a book. It's data which is used to describe or identify data, which is all that stuff in the pages. So the metadata is not strictly necessary to use the data, but it helps a lot in finding it, understanding it, and comparing it with other things. In this sense, you can really think of a library as one of the most important examples of metadata and a metadata repository. A library doesn't store your ocean recordings, it doesn't store your data, but think of how much valuable it is to be able to search through and find, your favorite Stephen King book by author, as compared to having to pour through a pile of books unlabeled on a stack. Even before we had computers where we can do full text searches or database searches, there were card catalogs where people would write down authors and what books they'd written, so that way, and where they were in the library, so that you could physically identify them in basically a database of cards. And that's sort of the theming, or sorting by theming by author, was done even with the numbering system of books nowadays. The Dewey Decimal, the Library of Congress systems are all based on theming as well. And that's a form of metadata too. So when we talk about a book then, if we're really going to focus in on the book metaphor, we can think of a book as having a lot of qualities and attributes beyond just the data on the page. Obviously, we can talk about things like font, title, number of pages, what the paper is made out of. I'd like you to take that example of a book you have in your minds and think about what's useful, what attributes and qualities are useful to you, and which ones aren't. And then I want you to take those attributes that you think are useful and think about when they could be used. Because I think something that's not very obvious about metadata is that the choice of attributes we pick here are biased by the context we intend to use it in, by our intended use. Probably you don't care what the physical size of a book is. Unless it's, large print or small print or something, or a picture book, maybe you care then. But, the fact that Stephen King's new novel is going to be 17 centimeters by 9 centimeters, that doesn't mean anything to you. But let's say you're a moving company or a delivery company that's shipping thousands and thousands of these books. Suddenly that size feels very important. You probably don't care about what type of paper the book's printed on. But if you're an archivist trying to preserve the book for 100 years, yeah, that's really important. Does it have acid in it? What properties do we need to care about? How do we preserve the text and the page structure so that it will be usable in 100 years? And even if we think about a different object entirely, even if a property is not useful for you in one context, like maybe we can think of situations where no one would ever care about the size of a book, you probably care about the size of a piece of furniture. And if a company didn't show how big a piece of furniture was, you might be very suspect of it. Whereas, if you go on your library website and it doesn't show you how big the book is, you're probably not going to think anything of it. Where metadata really starts taking hold is that we have to think about the audience and the purpose. We normally talk about metadata in the context of making your data findable, essentially putting it online in a way that people can use it and find it and locate it, and then you can point to your grant provider and say, I made my data public. That way, that proves I did the Tri-Council research statement on data sharing successfully. And your audience usually is then going to be your fellow researchers, your scientists, maybe policymakers, students, who could possibly benefit from using your data. Maybe it saves them time. Maybe it saves them money. Keeps them from having to redo research that you've already done. But of course, there are different purposes, like we talked about the archival situation. And that also has a slightly different audience in that it's trying to predict who the audience will be in 100 years, which may include historians or researchers or people who are trying to follow the development of society, sociologists. Or we could think about a situation where we have an internal records department where they need metadata to identify what forms are where, who has filled out, their non-disclosure agreements, who hasn't. But their audience is very limited there, and that way they can get away with different things than we would in a public situation. But there's a common thread here that you might be worried about, and that is that unless things are structured in some way, we have that card catalog, we have that database we search in a library, we have our data somewhere that Google can find it, or it's on some repository, it's kind of pointless. You upload your data as an unnamed file to your website and no one's going to be able to know what that is. You put a book, just on a shelf in a library without telling anyone about it, and they might not even, no one will ever know it's there. It might get lost or disappear and no one will notice. Really, that speaks to structuring the metadata in some way. I have the FAIR logo here because findable is the first letter of FAIR, and that was my talk on previously on Tuesday this week. And if you're interested in learning more about FAIR, I encourage you to watch the recording of that or to check out the FAIR principles. But metadata influences all the elements of FAIR, and you might see how as we progress. So on the idea of structure, once we start assigning uniformity to metadata, it becomes a lot more powerful and useful. So I'm again back to the book example where let's go think of finding that Stephen King book. But is he the author? Is he the creator? Is he a writer? And if all those things are different fields in your database, or just as different types of card catalogs, suddenly it becomes very confusing to find Stephen King. Am I going to find him under the creator list or under the writer list or under the author list or whatever? And this really speaks to how uniformity is key. So useful metadata adheres to this set of uniform rules. Everyone is going to be called an author if they wrote the book. There are going to be editors, there are going to be co-authors, there's not going to be creators, there's not going to be writers. If you call it that, it won't be right. So we call these sort of rules a metadata standard. And so standards always have some assumption of your purpose and your audience. When we think of the library example, author makes sense in there, and we probably have the title in there. But your metadata standard for a library will probably have something like who checked it out, because that's something that needs to be stored internally, maybe not shown to users. But whereas with the archival example, they probably don't need that. People can't take archival stuff home with them usually. Or even just for scientific papers. There, we can think of reasons why there would be an author and a co-author, or a creator, and a writer field, and that they might actually all mean different things, and it would be okay to have fields for each of those. And even the order of authors in scientific papers matters in a way that's maybe not as important for library books. So it's also important that when you choose a metadata standard, these rules that define how we describe things, that lay out the sort of framework of our descriptions, that we want to align it with our purpose and our intent. If we mismatch things, things start getting really weird and hard to describe. We might even see some of that a little later in our examples. Now, there's lots of different types of standards, and I know standards is a really scary word, but it doesn't have to be. There are lots of general and multidisciplinary metadata standards, and some of them are pretty small. They can be adapted with only 15 fields, like the Dublin Core Z is an incredibly general metadata standard used in a huge variety of places with only 15 things. Essentially, answer 15 questions and you're done. There's DataCite, which is used with the Federated Research Data Repository in an altered form, which has 19 fields. But now we're getting into another level of complexity there. A question has sub-questions within it there. Fields contain other fields. So a name, like the creator, breaks down into what type of name is this, and then a first name and a last name. And you can already see here that there's a little problem, that Dublin Core has 15 fields and DataCite has 19 fields, which means it's not going to be an easy photocopy job to just go between Dublin Core and DataCite. How do those extra 4 fields get filled? Which is part of the job of data management and something we normally call metadata crosswalking. And this is labor intensive, it requires human effort, and it's something that a lot of people don't want to deal with, and that's understandable because it can be a lot of work. And that's why it's important to essentially choose the right metadata standard from the start so that you're not redoing things multiple times. Filling in these 15 questions and then 19 questions feels like a lot more work than just filling in one of them, right? And then we get into the really, really specific ones, normally about what they're meant for. And as we get more specific, we can ask more specific questions about the data and things that really align with the purpose. So the example I go to, because it's one I'm very familiar with, is ISO 19115. Please don't buy this metadata standard because it's like 300 francs. I will just be talking about it. You don't need to download it or buy it. Maybe you'll want to later, but don't buy it because of me, please. ISO 19115 is for geographic information. It has hundreds of individual fields. Its simplest lower level container element, which is just talking about the people, well, it's talking about the metadata. It's literally metadata to describe the metadata, is 24 fields that contain other things, which suddenly can balloon up to take a lot of time, right? If you're asking that many questions, and especially when the appropriateness and how you answer certain questions may not be super obvious. But these fields are for things like spatial representation system. Are you using, GPS, or are you using one of the Canadian spatial representation systems? How the data was split up or collected, whether the data was modified or changed. Details on, binning and tinning of the data, how it's cut up or averaged or split up. And also connections between that data set and other related data sets, things on the same platform or cruise. Now, a really specific metadata standard might not be something you want to use. And it may not be useful for every case either. But the more domain and discipline specific you need to be, the more useful a domain and discipline specific metadata standard becomes. And if everyone else in your field is using a certain metadata standard, it becomes more valuable for you to choose that one, because then it's really easy to compare them. The problem that you may not have thought about is that you might not have a choice in what you pick. You might be forced down one of these paths. You might not know it, but each metadata repository is going to be following a certain metadata standard. They might mask that from you, but in the end, that's what's going on, is them choosing a metadata standard for you and prompting you to fill that in. And there's another catch, which is that, you want to make sure your data is found by the people who can benefit from it. As I said on the last slide, if you are in a discipline where everyone else is sharing their metadata in a certain standard, you want to be using the same standard, so that way it can be really easy to compare your metadata, and that way decide which of your data sets is more appropriate for a problem. Essentially, it's making the structure the same, which benefits using a computer to analyze it. And if you're using a specific repository, then you have to use the metadata standard. And I think both scenarios here really benefit from choosing a discipline-specific metadata standard over a more general one, because it gives you more power to describe your metadata, or to describe your data in more detail and answer more questions about the data before they have to send you an email, before they have to call you and pull you aside at a conference and say, I don't understand the data you shared last week. Now, I know you're all probably thinking a general standard is going to be so much easier though. Look at this, 15 fields as compared to hundreds. And sure, if you are the only one in that field, and you're the only one who has to answer questions about your data, you can fill a more simple one. But it might also hide information that people really need to understand. For example, if you don't talk about the spatial representation in geographic data, people are probably going to be confused why you have fishing data that doesn't line up with coastlines, like why it's on land when you're talking about deep sea ocean fishing, just because the spatial representation system isn't correct. What I mean by obscuring or omitting key information. But as I sort of briefly hinted at last time on the last slide, a metadata repository will try to make it easier for you to fill out. They'll obscure the metadata standard from you probably, and they also obscure it from the end users by giving them usually a computer search that gets rid of a lot of the jargon and hides stuff that users can't use. Metadata providers also track a lot of hidden stuff usually. Like Google is essentially a metadata repository where the metadata is pulled from websites using full text searching and the actual metadata built into the web page. But Google also has a ton of variables that they track associated with each web page. That's how they assign which ones appear at the top of your Google results, which you never see, and probably no one outside Google will ever see those numbers. But that's more metadata that's stored in their system somewhere associated with the data that is that web page. Now we've talked about standards. Standards are essentially a more theoretical level. They're not usually designed to be implemented directly. It's often adapted more by users, users in a specific part of the world or in a specific discipline to suit their needs in that part of the world or that discipline. So ISO 19105 has an adaptation made by North American scientists and one from Australian scientists as well, but they're not the same. These individual things are essentially profiles of the metadata standard. Well, they're called profiles. Profiles can either add new restrictions to a standard, making it smaller by saying, if I have a field named name has to appear in order, last name, comma first. Or we don't think the field on currency system is useful, so we'll admit that. But sometimes they can also add new fields and make it bigger. It's not as common, but it's still done. One example is the marine community profile, which identified some problems with ISO 19105 and decided to add some of their own fields to fill that gap that they had identified for their use case. So that again adds problems. Each of these profiles now has to be translated in some way if they need to adhere to other profiles. And I've also done a little bit of a mission here in that metadata repositories usually follow a profile, which is going to be different from the standard. And again, profiles are usually, once they're chosen, they're not changed just because it's so difficult to change things after the fact. Imagine, a library buying 100 books, filling in their library database, and then deciding, oh, we're also going to record the page counts of all these 100 books, which they didn't have before. So now someone has to pull those 100 books off the shelf, read the number of pages, and write it down, which is just a pain in the butt, right? And then once we start talking about actually writing down metadata, and we create what I call a metadata document, is using a set of rules called a schema. Schemas are specific to profiles and an output format. And they might include changes that satisfy things in that output format. And sometimes they can even include small changes to a profile, usually with conditionality. A profile might have a complex rule system for, this field appears when the XYZ happens, but a schema might not be able to check if that's always true. And there are lots of different output formats. XML is a pretty common one for extended markup language. But you can also see things like just plain text or comma-separated values. So an example of how your output format changes your metadata. For example, in comma-separated values, if you include free text fields where people can write down commas, suddenly those have to be stripped out or modified in some way so that the CSV file doesn't get really hard to parse. Schemas also usually have a structure to them, which helps them identify what any given piece of metadata means. The simplest way to think of the structure is just the order in which fields appear, so that even if the fields weren't labeled, you would know which ones they are just by the order they appear in. In XML, with ISO 19105, often a lot of this structure is by giving things identifying names and nesting things together. A field contains a person has a name is a free text value, and then the free text value is the name itself as you enter it. And you can see how that structure provides extra context to what that metadata means that you might not get just by writing down a name. And the more complex we make a profile, the more complex structure has to be. So let's summarize all the jargon I've thrown at you, and hopefully you've followed along. So metadata is how we describe things. Metadata standards are how we make metadata useful and interoperable by assigning an overall structure and rules that say what has to be provided and what doesn't have to be provided. They may target specific users or use cases, but often that's further specified in a profile. So you might have a specific use case or user group in a profile. For example, North American scientists working on geographic data have the North American profile of ISO 19115. From there, we have the schemas, which is how that metadata is written down. It becomes a document. And then we have the metadata document, which is a thing that contains all the metadata about a given resource, a piece of data, or a book, or any example we think of that needs metadata. So I think the easiest way to think about a metadata document, which is what I'm going to be trying to focus on from here, is that it is a series of fields or questions and answers governed by the rules of the schema and the profile, which contain all the information necessary to describe that associated resource. And then you can break that down, if you want to, into just essentially a list of things you fill out. You know, you have a list of questions from 1 to 20, and that is your metadata. You might make a metadata document yourself to literally write out that XML and fill in all the fields yourself. Sometimes there are tools that will generate the document. Usually a metadata repository will provide a web form of some variety to fill out metadata if they allow online submission. And then they'll make the metadata document themselves using some tool. And a metadata document that satisfies the rules of the schema or the profile that it's meant to be following is said to be conforming, compliant, or valid. You'll see all three of those words thrown around. So I really hope if you ever feel stuck, especially later on, or confused when we're working with metadata, is that it's really just a series of fields, a list of questions with answers that we fill out. So I think the easiest way you can ever understand a profile is walking through it field by field. So this is an example of what a Dublin Core element set field looks like. They call them terms. It doesn't really mean any difference. I don't think there's a uniform name for what they're really called. I like fields with values, but not everyone's going to use that. So their term, here it's language. And I'm going to break it down a little more on the next slide. The first thing we have there is a URI, a unique resource identifier, which is, in this case, it's a web link to always get back to this field. Essentially, it's a way to add cross-references back to this document easily and get to that exact place. We have the label, which is the name of the term. We have the definition, which is what it's supposed to mean. A comment, which is additional details. And in this case, if you can read that, the comment says recommended best practice is to use a controlled vocabulary, such as RFC 4646. And then there's a reference out to that document. So probably you haven't heard the term controlled vocabulary before. So I'm going to walk through a little bit of what that looks like on the next slide. Essentially, a controlled vocabulary is rules that define what goes in a field. So even more rules on top of the schema that we talked about, the schema and the profiles. Sometimes you'll hear it referred to as a code list. So Dublin Core has a code list for the type of data that it collects. This is an example of date types in ISO 19115. So essentially giving additional context on why a given date is recorded in the metadata. And you can see there's usually a name and a definition. There's also a domain code, but that's more for writing the schema itself, machine readability. So now inside the fields, there may be specific rules defined by a controlled vocabulary. This also occurs in other ways, but I'll talk about that a little bit later. And I also want to walk through this sample ISO 19115 field, which is about dates, since we talked about the date code list on the last slide. I think the useful information is down here in the text. I have a pointer now. The graphic above does contain information and context about the metadata profile, and in a lot of ways you can interpret the structure using only the diagram, but that's a much more advanced topic, so I'm not going to be focusing on it. So the parts I want to focus on the text, just going one by one. If we're looking at the field date, which is referred to as GMD date in the picture, starts with a little description, the date in which the event or action occurred. There's a type, which is what sort of fields it contains, essentially what type of data can go in there. In this case, it's a date or a date time. There's a domain, which is essentially referring to what valid values in that field are. In this case, it's a date. There's multiplicity, which is how often it occurs and whether it occurs, or whether it is required. So how often it occurs, whether it's required. You'll see things like optional, repeatable, mandatory. Conditional is common. Conditional means that it may be mandatory in one case and optional in another case. And then there's also attributes, which is additional data referring to how the schema, the document itself, is written in conformance with the schema. I don't think it's useful to talk about that in this case, just because you're not going to be writing an XML document where attributes matter most of the time. So note how there are fields inside fields. In this case, and this actually does refer to a structure. You know, there's a date which has a type assigned by that code, and there's the date itself, which could be a date, or it could be a date with a time attached to it. There's also potentially formatting rules that go beyond code lists. Dates and times are commonly formatted in one way. Normally, they're formatted according to ISO 601, which is year, 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 dash, month, month, dash, day, day. ISO 8601 is described pretty robustly online for free if you're ever interested in that. Things like temperatures, whether they should be recorded in Kelvin, Celsius, or Fahrenheit, since often a temperature field will be a number and not support text. And then there's also the code lists, as we talked about. At this point, I would stop to ask for questions, but I think there's no one participating. So I think I'll just move on, unless someone yells at me.
It looks like we do have one participant, Caitlin Bate. Caitlin, if you have any questions, you're welcome to raise your hand or just post them to Kim, and if not, we'll just move on.
Okay, I'll move on then.
Please carry on. Yeah.
So the exercise I was hoping to cover today, and maybe you'll feel interested in doing it on your own, is about creating a metadata document on your own. So I'm not going to ask you to fill out a giant XML document, but I'll give you some more details on what I'm anticipating would have happened in the next slide, or over this slide. So using one of Dublin Core, and the Dublin Core elements at the 15 questions, one that I mentioned earlier, or ISO 19115, I'd say for that one, focus only on the data identification part of the profile. Given a data set, which has some metadata associated with it already, how would you describe it in this other metadata standard? And I would say you're free to use any other resources that you would see fit to assist you. And I have another slide here. I'm going to stop my sharing and open up my web browser so I can show off Dublin Core and the data set. Stop. Share screen. That one, no, this one. Just need to move that to the bottom. You can see my presentation. So this is the Dublin Core metadata element set web page. It's, as it says here, this is somewhat out of date. but I think it's good enough for our case. There's a whole introduction here describing how it works, how it's referred to, how it was made, what it means. But really, the useful stuff is down here, beginning with the elements. So each of these terms is one of the 15 terms in Dublin Core. The Dublin Core element set anyways. There's a lot more in Dublin Core metadata terms, which is a related standard. And the data set is this one from Open Data Nova Scotia for environmental monitoring program data for aquaculture. In this case, there is some metadata here already. It's not structured in a way according to Dublin Core, but there are definitely things here that we can use in Dublin Core. There's also some more metadata over here that's structured a little differently. We have an overview of how big the data set is, how many columns are in it, what they're called, and what values are in it, which is essentially that value restriction I mentioned. And then we can see a preview of the table where there are the columns and the data themselves. And you may find it useful if you use the Visualize button, where you can export it and download it, either as an Excel file or CSV file, and then you can import it into your graphing program of choice. But the Visualize tool is fairly robust. It's good enough, I think, for the examples I'm interested in. I'd like to show you how I can figure out or see what the minimum and maximum latitudes and longitudes are, essentially what the geographic scope of the data set is. So in this case, I just selected my x-axis as latitude, switched over to a scatter chart along the top, and then I have longitude as my y-axis. In this case, you can see it goes from, minus 60 something, minus 66.3 or so in longitude, up to minus 60.5. And then there's equally a scope in latitude. Going back, yep. The field I want to focus on just for my example, because I'm sure people will think it's pretty easy, but I would like to point out a lot of caveats in there, is date. So date is described as a point or period of time associated with an event in the life cycle of the resource. In this case, they say date may be used to express temporal information at any level of granularity, and best practice is to use an encoding scheme such as ISO 8601. And then here's a link to about how ISO 8601 works. So from looking at this page here, there are lots of dates here. There is updated June 9th. We can see data last updated on June 9th, metadata last updated on June 9th, date created in 2018. There's a time period coverage from 2009 to 2019. And there's also a field in the data set called date. If we hit view data, this will now have all the rows in it and all the columns. If I sort date ascending, we can see the first date is 2009. And then descending, the last date is in 2019. So that corresponds to this time period coverage here. So when we think about date, I think there's multiple answers that would be acceptable in this field. I think there's one that's best or better, but that's not necessarily the only one you might see. So I think the most useful one is identifying the time period coverage from 2009 to 2019. And we can get more specific if we go into view data and see date from July 8th, 2009 to December 18th, 2019. I'm just going to scroll through this briefly to make sure I'm not getting June or something missed. July, August, September, yeah. It was entirely possible this was sorting by alphabetical, and therefore things might get a little weird, but it seems like it's doing it by proper date. And probably if we exported the data, we'd be able to see that it was recorded as a full numerical date. So in this case, I'm gonna open up this note on date time. And yeah, this actually doesn't talk about periods, but there is a way to describe periods in ISO 8601, which you can find on Wikipedia. And I guess I'll pull that up. So under durations, so period or time intervals, where it is a date and time in ISO 8601, and then separate it by a slash is the end. So in this case, I might say something like date is 2009-07-08 slash 2019-12-18. I think it would be equally valid if we wrote the date of creation of the final update for June 9th, 2020, even though there's no data from 2020 in here. I think there is an argument you could make that recording the date the data set was originally uploaded in 2018 could be recorded as well. You might even want to record all of them if we wanted to repeat the Dublin Core field multiple times. There's no specification here for multiplicity, like there is in ISO 8601. So that would be valid in certain interpretations of this element set. If we were forced to have one, I think the most useful one would be the 2009 to 2019 coverage period. But 2020 is the date it was last updated, or the 2018 is the date it was created, could also appear here. I guess I will take a moment here to also talk about type. Type is one with a controlled vocabulary, which is supposed to be about the nature or genre of the resource. If we follow this link to learn about type, unfortunately it doesn't take us directly to it. And it's not really in a nice list like ISO 19115 is. But there's a term here for collection, dataset, event, image, interactive resource. These are the components, the individual elements in the controlled vocabulary. So these would be the valid entries in the type field given strict conformance to the type vocabulary. In our case, I think the correct answer here would be dataset, because it gives the example here of lists, tables, and databases, which is definitely what we have in the example here. I don't think collection is great because it's not a group of parts. If we were talking about a singular moment in the environmental monitoring program, it might be an event. If we were talking about the website as the resource, I think that would be an interactive resource. or potentially a service. But I believe the Open Data Nova Scotia site is more of the service than this particular data set on the website being a service. And you might even have an argument for the resource being text, since you can export it in CSV. But text is specifically for things that are meant for reading. You would never read a CSV file, like you would a book. So I don't think that's appropriate here. I'm going to switch back to my presentation. So for completing this exercise at home, I think the easiest way to do it would be open your text document editor of choice, Notepad or Word or something like that, and make a list of all the fields in the Dublin Core element set and fill them in one by one. So you'd start with, you'd start somewhere around date and end with type. As I mentioned, you might want to download the complete data set, but the visualizer tool is also available online and can be really helpful. I think that not all of the metadata on that page is related to the data in the data set. I don't think it's necessarily relevant that the data set was last updated on the website on June 9th, because that doesn't reflect anything actually in the data set itself, which is what we're actually trying to get at. And a lot of the data in the data set itself isn't going to be useful either. It probably doesn't matter each of the individual aquaculture points and licenses. In ISO 19115, there's also fields that talk about the metadata itself. So it's metadata within the metadata talking about itself. In that case, if you're using that profile, I'd recommend you try to remember that you're the ones that are creating the metadata. The data set is something by someone else. So you're not the author or the creator in most fields referring to the resource. But if the field's referring to the metadata, that is you. The other thing is, the last point, I guess, is remember the purpose of this. What is useful and not useful to people when it comes to understanding the resource? And what are the likely use cases of it? In this case, it's likely that someone is going to want to download this and access information about aquaculture in Nova Scotia. If they see last modified June 9th, and it even says on that webpage, accurate up to June 8th, 2020, but there's no data at all about 2020 in there, they're probably going to feel confused and maybe even, like the data set lied to them, which is why I don't think that June 2020 date is that useful in date fields. I think there are going to be some fields that you found really easy, and there are going to be some fields that you found really hard to fill in. And that's completely normal. It's pretty easy for metadata profiles and schemas to be full of jargon. And it may be jargon that really you get, you have a complete grasp of it, and you're just like, oh, I know exactly what that's referring to. Or it might be jargon that you've never seen before, and you'll just go, I have no idea what they're trying to say. And you'll have to think about it and come at it from different angles and maybe even find examples to look at. And that's normal. That happens to me, that happens to other data managers. It's not something to be ashamed of. I think the other thing is, if you compare the results to someone else, you might not agree on all the fields. The choice of values, even within the Dublin Core element set, is not going to be, there's not a single correct answer, I don't think. There are probably going to be fields where people just don't agree. Like, I think you could probably make an argument, and based on an assumption that it is actually text output, and yes, you could read a CSV file, that yeah, the resource is text, or that the date should be 2020 for some reason. Maybe it's just me who's thinking, oh, 2020 is not useful. And I think that is something that really benefits in this case from comparing with someone else. So if you have that opportunity to compare your work with someone else, I think you should take it. So if I had final advice for you, if you just had 4 things you could take away from this talk, it would be: first, you should choose your repository because that might determine your profile and your standard, and then save you all the work of thinking about that and really even caring about what they are. I think bad metadata is just as bad as no metadata. As I might argue in the case for June 2020 being a bad date, people are going to not feel good about not being able to find 2020 data in a data set that claims it's accurate up to June 2020. Metadata is about making your data more findable, more accessible, comparable to other people's data. And the secret thing that no one tells you is that it's actually about saving you time. Because the more metadata you provide and the better it is, the less likely people are ever going to come up to you and be like, I don't understand your data. I need your help. Please explain to me how you got from point A to point B in your analysis. The more robust your metadata is, the less likely that's ever going to come up. And then think of it. Then you're on your beach in Bahamas or Jamaica whenever the planes start flying again, and you're free to travel. And you're not answering emails about the data set you uploaded last week. The last thing I want to say, and I mentioned this, I think, during my FAIR talk, is that you should think about metadata early on in the data collection cycle. There's some metadata that is best recorded as it happens. Things like your experimental procedure, how errors were corrected or detected, who collected the data, the purpose. That sort of stuff might get forgotten or otherwise misremembered if you put it off until after your data is all collected and maybe your records aren't 100% complete. So if you start recording metadata early, there's less likely that that's going to happen to you. Of course, FAIR also wants you to have metadata available forever, and that's a whole different thing. I'd like to thank everyone for listening to this presentation. I hope it was at least useful to some of you and provided some interesting thinking for others. Thanks for sticking through with me and for participating in these examples with me.
Thank you, Kim. Before we wrap up, there's now an opportunity for our live audience to ask any questions.
Yep.
And you can do that if you have a question by writing in the chat. No questions from Caitlin, who says great talk.
Any questions from the co-hosts? If not, then I guess we're done here.
Yeah, as a very final thing, I just want to, if you're watching this offline after it was recorded, thank you for watching. And if this has triggered any questions, I think you're very welcome to approach Kim. And you can find Kim's contact details by going to Meridian's website, which is meridian.cs.bal.ca. And while you're there, you're very welcome also to explore some of the other projects that Meridian is working on. On our YouTube channel, you'll be able to find recordings of other presentations given as part of this small workshop series on ocean data management.
I'll also be sharing my complete presentation as a PowerPoint, complete with speaker notes, if people are interested in having that as well.
Excellent. Yeah, that will be made available through our website as well. And I think that is everything. So thanks again for watching, and till next time.